We have the integral of x plus 5 over x squared plus 4x plus 13 to evaluate. We're going to give this a try. Go ahead and pause the video, and I'll be right back. Now we do have a rational expression for the integrand, but the denominator doesn't factor. So what I'm going to do is try to complete the square. Got the coefficient here of the square term of 1. So we know we take half the middle term and square it. Half of 4 is 2. Squared we get 4. That's got to factor this, or make this a perfect square. This factors into x plus 2, quantity squared. It will give me x squared plus 4x plus 4. But I can't change it here, so I still got to put a plus 9. So we wind up with the same thing we started. 4, 9 is still going to be 13. This will be plus 9 here. So then we can rewrite this as the integral of x plus 5 over, and I'm going to let u equal to x plus 2. So in the denominator, well, let me do this first now. Du then, du would equal to the derivative of x plus 2 is 1, so this will be dx. So in the denominator then, the x plus 2 will be your u, so this will be u squared plus 9. And then of course, du and dx are the same. So I put a du here. Now I need to replace the x plus 5 by something to make it into an expression involving the variable u. Let's see, x, if I solve this for x here, right here, x will equal to u minus 2. And I want something for x plus 5, so let's add 5 to both sides here. So I get x plus 5, and 5 added to this side will give us u plus 3. So now instead of x plus 5, I can put u plus 3 here. And now we continue. I'm going to break this up into two integrals, so I'm going to write this as u over u squared plus 9. This will be, again, the variable here is just u, so this will be du, and then it'll be plus the integral of 3 over u squared plus 9. And we have that. Now notice here, the derivative of u squared plus 9 is 2u, and I got a u in the numerator, so I can use another U-Substitution to integrate this. And this one over here, I have 3 over u squared plus 9. I could factor out the 3 here, and then I would have this integral right here. Anytime you have anything that looks like this, integral of, say, du over u squared plus some other number squared. So again, this is a 9 here. This is a 9. So it's u squared plus 9. Anything that has that kind of look. And well, let me put an a there because I want it to look like the formula here. So let me make this an a here. So I got u squared plus a squared in the denominator, and the formula for that, got any integral that looks like that, the value of the solution to that is 1 over a arctan, arctangent, and this will be of u over a. And you're going to have a constant of integration over here. And in our case here, I said the 3 can be factored over here, so this just be du over u squared plus 9. So the u Of course, in this case, it's going to be u, and that eventually is equal to x plus 2 from over here. And the a is just 9 here. So 3 squared is 9, so the a would be 3. So this is easy to integrate now. So let's do it this way then. I'm going to do the second one first. So this is going to be a plus here. Factor out the 3 here, so this will be a 3 out here. And then it's arctangent of u over a. And again, from over here, u is x plus 2. So this is x plus 2 over a. A is 3. Because we've got 9 squared, or 9 there, which is 3 squared. And then we divide the coefficient here by 3, or a. So this will be a 3 here. Got a constant of integration over here. See? And then 3 divided by 3 is 1. So these cancel out. So the second integral is arctangent of x plus 2 over 3. And I've got the constant of integration. Now for this one right here, you should be able to do it without the substitution, but I'm going to use another U-Substitution. I'm going to call this U1 just to make it different. So U1 will equal to u squared plus 9. You can do it without this, but just to make it clear, this then would be du1. On the right side, I take the derivative with respect to u, so this will be 2u. Derivative of 9 is 0. And then this will be du. So then this is going to equal 2. Now we're going to convert to u1. So I can replace the du, divide here by 2. So this will be du1 over 2. So du can be replaced by du1 over u squared plus 9. That's your u1. So this will be u1 here. And then the 1/2 is out in front. Again, the only difference, instead of du over u, it's du1, u1, just to change the variable. Okay. So I don't use the same u. And of course, this is your formula for the natural log of u1. But what is u1? u1 is u squared plus 9. But what is u squared plus 9? U squared plus 9. It's going to give us this right here. So I can rewrite this then as 1/2 natural log of the absolute value of u1. But like I said, u1 is u squared plus 9, and u squared plus 9 is x squared plus 4x plus 13. And you can check this, but this is always going to be positive. This is a parabola that opens up. It's above the x-axis, so we can go ahead and leave the absolute values off. And this one we just bring down. So this is our final answer then. 1/2 natural log of x squared plus 4x plus 13 plus arctan of x plus 2 over 3 plus your constant of integration. Thanks for watching. We'll see you next time.